lecture, you learn how to design an API, right? What is RESTful APIs, or what is RESTful, what is REST APIs, all this stuff. You have learned all this stuff, right? And today I will tell you that not every API is as beautiful as it should be. So when we're working with APIs, we have to learn that not every API is the same, not every API acts the same, not every API is documented the same. And yeah, so talking with APIs, it can be challenging to find out which API behaves in which certain ways, how do we have to handle them, are they really REST or are they not REST? All this stuff is something we have to keep in mind. So yeah, just as a reference again, API, application programming interface, you all know that, and representational state transfer for REST. So many times we talk about REST APIs. One thing we have to ask ourselves is it really REST or is it just marketing? But the goal from today is to understand the principle of REST. If you have application architecture already visited, you have this knowledge already. But also to keep in mind what does it mean for us as a network automation expert. If we want to automate something, what does it mean for us? What do we have to consider? And then, of course, we need to know how to apply this in our automation tasks. And then, as one of the examples of APIs we use a lot, will then be RESTconf, the border to the Netconf we have already seen 2 weeks ago. So, REST itself, as a recap, it's definitely a client-server architecture where the piece of software who makes the request is the client, asks some information. It's pretty simple design. It has to be stateless to be REST. So each call we do needs to give us information. So one call cannot depend on the call before. We have cache model, so REST APIs, they are able to cache if it's possible, or they have this integrated. We have a uniform interface, so we have defined how everything has to look. Layered system with abstraction design that we can scale, for example, and code on demand, optional. I was thinking yesterday if I have seen this in practice somewhere, so that would mean that on certain API endpoints I could download specific code snippets for example, dealing with hashes. I'm not really sure if I have seen it in the REST, depends how you say the code download, but yeah, will not be important for us. Otherwise, Olaf Zimmermann can definitely give you more insights on this. REST itself uses the HTTP protocol, so protocol we use a lot, we know how it works, we have good libraries, and of course we're using the HTTP verbs get, post, put, delete for the CRUD operations, right? And yeah, then we have the HTTP status codes, 200 OK, everything you know, I hope. If you have any questions, then let me know. And of course we have the header and body where we can send information, tokens, payload, all this stuff should be familiar to you. In REST we also need to address our resources, because an API we can create, update, delete, what did I miss? CRUD. Create, read, update, delete resources. So we have the schema itself, that's HTTP or HTTPS, hopefully HTTPS, hopefully with a real certificate and not verified like false. We have the authority, so the server, the URL, and then we have the path to the resource with the hierarchical design, and then we can have queries for filtering, scope, all this stuff. Everything already known, right? Okay. So, marketing loves to call everything REST. So be aware that if the documentation tells you it's a REST API, or if the marketing tells you it's a REST API, it does not mean it has to be a REST API. And yeah, not all APIs are created equally. I have seen some really strange behaving APIs. This is one of the examples here. If I see something like this, it annoys me. So if we make a get, and here we say we want also to print the HTTP code, that's just to show it, we get a 200 OK. So the request was OK, but if we look into the message we received, it tells us it is a bad request. So if you design an API and you would do like something like this, please consider to change the job. It's just we have the status code, and I have seen APIs where you cannot rely on the status code, and it's really annoying. And yeah, but the problem is, or why I'm telling you this is, we have to be aware that this can happen. It's more often than we think. And officially, there would be even a RFC standard who defines a standardized JSON format how an error message should look like. But I have not seen this implemented so much. But if you create a new API, probably you have learned from Olaf that this RFC is here and how the error message should look. So that would be nice. One thing when we go into automation, we can see often is this 429 message. Who has seen this message here? 1, 2. So what we have here is rate limit issues. If we make a lot of API calls, the server has to protect themselves from overloading, right? So normally we implement, yeah, you know all this pattern, I believe. So we implement the rate limit pattern to protect that no one can DDoS our API. That also means that if I have too many requests, I have to wait. One of the important things is, if we design our automation, think about how many API calls you really need. Is there a way to make maybe bigger API calls and store the data? Can you optimize your code? Then if you automate for, let's say, 50,000 devices, and you need an API call for each device, then there are 50,000 API calls. If you will need a second API call to also get the interface information, for example, it will have double. And depending how you write your code, this can in the end lead to big issues. One of the issues also is, if you develop and if you test, you most likely will not hit this error. But if you go to production on the real data, then suddenly your code is failing because you did not consider that there is maybe a rate limit on the third-party appliance you're talking to. So always keep in mind, each API should have rate limits. Not sure if they implemented it correctly, but yeah, if you talk to APIs, think about rate limits, especially if you know that as soon as you go to the production, the number of API calls will be bigger. Another solution is maybe think about GraphQL APIs, where you can make less API calls to get the same information maybe. That would be also an option. But if you design your automation task, just always keep in mind that you have to deal with this kind of stuff. Right. So how does rate limit work? How do we deal with it? So when we get this message, we make a delay. Okay, we add a delay every time we hit this error code. Let's say drink a coffee, and then 5 minutes later try again. Could be an approach, right? A simple implementation. Maybe there is a better way. Depending if I think we have to be aware that this error can happen, and we also need to be aware how often this maybe happen. If we know that we will hit this multiple times, it is worth it to solve it nicely. If we know we hit it every week once in our code, and we don't really care how long the execution of our code is, we can definitely do a delay or a retry or something. But if it's implemented correctly, we have some information from the API how to deal with it. Rate limit implementations are mainly divided in 4 different algorithms on the server side. So we have a leaky bucket, that's kind of water drops coming out and we can consume them. We have a token bucket where we have a bucket of tokens. Tokens come in, but if I have a burst, I can empty the bucket faster, and then I have to wait until the tokens are coming again. Then we have fixed window counter. So we have a fixed window, for example, for each minute I have 60 tokens. So when the minute starts, it fixes. I can make 60 requests. Afterwards I have to wait until the next minute comes. And then the third option would be this sliding window, where we also have a fixed number of tokens, but it's not fixed for 1 minute, but it's just for the actual minute at the moment. So it slides this window. These are 4 implementations we see, and most of the time the API documentation or the server implementation, the documentation should tell us which kind of strategy they have. It's not always the case. And what we have and what they should provide are these header informations with limit, X-rate limit, remaining, and reset. So kind of when do we have more tokens again to make API calls. One of the APIs who is easy to use for demonstration would be GitHub. So if I would make a curl, I use -e for seeing only the header informations, -s for silent, so that I see the progress bar, so the output is a little smaller, and I only interested to get all the rate limit headers. And then I see we have a limit of 60. I still have 34 tokens remaining I can use, and at this timestamp it will be reset. Depending on the API, maybe I have more information. So for example, I also see that I used already 26 of the tokens. But if I would now make a lot of API calls to the GitHub, for example for all the repositories, at one point I will hit this rate limit, and then I have to wait. And if I know this information, it's not so hard to implement a delay algorithms, for example, who is a little bit smarter and waits until the limit is reset. Right? So this header information we normally have from an API, if the API developer was a nice guy. So another thing we see a lot is pagination. So if we in a lab do something, many times we make tests with small data sets, maybe then we don't need any pagination. But as soon as we need API calls to get data from 50,000 devices, we most certainly have in the third party tools pagination, and then we have to deal with this. There is also some different implementations how it should be done or not. The nice way to do it is RFC2488 with the link header. Who has seen this? Who has used this? So I had to slightly change the format because this would be one line, but then it does not fit on my slide. So if we now make an API call and use the queries, I want to have page 1 and per page 9. I also had to change this number so it fits nicely. We can say on which page we want to be, how many entrants we have in this page. One thing, if you're working with the GitHub API, for example, it does always do pagination, but if you are not aware of it, you probably will not see it. You will just see the first, I'm not sure, 20 or 25 items. And then the request is over. And then you have to know that how they implemented it with the RFC, that there is a header set called link, and then we have there a next and the last link. As soon as we are not on the first page, there will be also a previous link and the first link. So we have up to 4 links there. And this should give us the direct next link. So what does it mean? We should not meet to increase this number and iterate over the API. Who has done that? Who has ever dealt with pagination APIs? So it's our life much easier if we can just access this next link property, right? Because then the API does all the work. It tells me already, look, to get the next data set, just use this URL, page 2, with the same values, of course, because otherwise it will be not matching. But yeah. So there is also officially from Mirko and Olaf this pattern. I put the link there, but it's really common to have pagination. And I did a really small Python demo, because you're all Python experts. This should be reading like a poem, I hope. So requests is kind of the most used library for HTTP interactions. Well, that would be a built-in, but almost no one used the built-in library. There would be also a HTTPX library who has kind of the same interface as request, but also supports async. Also like this library, but this is definitely the most used, so the example is with this one. We have a function who will just accept a URL as a string, will not return anything in this case. And now I have a while with the URL. The first step, I pass here the first URL I have, and then I make the GET request. I will raise an exception if this is not a 200 something status code. Of course, if I raise an exception somewhere, I should catch it. In our case, no one will catch it, and I will see the really nice ugly traceback. But at least I have some error handling. Then for the data I get, I know it is JSON, so I can directly use JSON to get the Python appropriate data types, I iterate over the repos, and I will get the full name. I use here of this dictionary the get method with the idea that if there would be something else in, I would just get none. And if I would use the square brackets, I would get a type error, or no, a key error, key not found, if the key would not be there. So get, we get a default value, and we use the f string to just print out the name. And to get the next URL now, we can directly go to links. This will be a dictionary. On the dictionary we can say I want to get the next one, because on the last page there will be no next one. As a default value I return an empty dictionary, so that this command here will not fail, because I want to get from this dictionary the URL property. And yeah, this code runs will print all the repository I have forked or somehow in my GitHub profile. It's just a simple example, of course you have to adapt it. What is missing here? Nothing missing? Is this code perfect? What was the topic before? Before pagination we were talking about rate limits. So here I have absolutely no rate limit handling. So as soon as I hit the rate limit, I execute the scripts a couple of times, or I have more than here I use 10, so I have more than 600 repos. Wait, 6,000 repos. Then I would hit this exception here. So what we would need to do is also to add some logic to avoid the rate limit, right? But then it would not fit in my slide so perfectly nice. That's clear? But Python, pretty elegant I would say, to get all the stuff. We don't have any counters we have to bring up. We don't really need to store all the information in the memory. Just the next time we overwrite the response, because we had already done our task, so we can also implement some nicer ways to deal with APIs. And that's especially handy if we are talking about large scale networks. So I will not talk about more about REST APIs, because as I said you have other modules. You will learn, or you have learned, how to implement them correctly, so you should also be able to use them. Most important thing, don't trust documentation. Not every API is built nicely, and not everything is really REST when the REST is on the package. Yeah, so one thing we in the network automation see often, not so often, but it's still a thing, is this RESTconf, right? So when we talk about Netconf, we used SSH to send XML data to our device. Our daily life as a modern developer, we are really used to use JSON. But with Netconf we have to use XML. Of course we will find our way to deal with XML, but if we want to use JSON, there would be the option of RESTconf or gRPC with the GNMI interface. So this acts like a RESTful API, kind of. We have also here the HTTP verbs get, patch, put, delete and add, and we can then do action on our data structure. So we can read information, we can patch or merge information, we can create new information. For example, if we want to create a new entry in an access list, we can post information to create completely new. With the put, we will replace something who is existing. So we can, in one API call, we can, for example, replace the whole BGP config. I'm not sure if it's a wise choice, but we can. We can delete information, and with the head, we can just see the HTTP header, some information about this endpoint. Let me just open the documentation. If it's open in the right window. So I'm not sure which version we have at the moment in the lab, but I would say this was the first version who was kind of nice to work with it, with APIs. Here we have the same table with the information. We can also then call RPC calls, for example, for reloading a device, for deleting a file. So that would be in this section here with the post. And we can also get some schemas information. And here we have some example URLs. I will have some on the slide as well. So with the path, we can identify the resource we want to talk to it. So for example, an interface, and then we can make a CRUD operation on this interface by sending the right information. One important thing when you start using RESTconf is that Cisco, in our case here, really needs to have the correct header set, for example. So we need to have this special application yang data JSON header if we want to send and receive JSON, and it has to be exactly this format. This is the stuff we send, right? But we can also then no, this is a response. Here is what we accept. So we have to say which format we are using to send and which format would we expect. We can also get XML. So if we have the XML already for Netconf, we can use the XML also to send it to the device with the REST API. But yeah, keep aware, you have to handle the accept and content header correctly. You can send JSON and you can receive XML, or you can send XML and send JSON. I normally always try to use JSON. I had some platforms on some versions where I had some bugs with JSON, so I had some API calls with XML. But if I can choose, I definitely try to use JSON, just because I'm more familiar with JSON, how to deal it. It is for me more Pythonic to do JSON than XML. Of course, with X3 and all the stuff, we have a lot of capabilities to deal with XML, but yeah, I'm used to APIs, so I'm used to JSON. And I assume every year it gets more extreme that XML probably will never these things go away completely, XML. But if we have the choice, JSON will be always winning, in my opinion. We have the methods here, the capabilities we can see, and one of the important thing is we also get error messages, right? This is a special. It's not the normal RFC error message format, but it's the RESTconf error format. We can see we have a error tag, we have a path, object already exists. So here was we try to create a host name, but the host name is already there, so we cannot create a new host name. We need to update. So we use the wrong operation, CRUD operation here. Yeah, you have many examples here in the lab. You can also try this out if you want, but I assume you will work on the CI/CD lab in the lab. But if you have any questions, you can always also come and ask. So these are different examples how we would then address our resources. So for example, if we want to have this all availables APIs, we would make this API call to get all the Yang models supported. If we want to use the Cisco native model, we have here the native and then host name. You have to get used to the URL. It's, yeah, sometimes to find the right URL it's a little painful. When you talk, for example, for BGP, from the model itself we have BGP, and BGP has a AS number as a key, so we have to define on which BGP instance do we access. Even if the Cisco iOS XE only has one BGP session, we have to specify to which. So we need the equal to say we want to talk to the 512. After that we still can continue, so the URL can get quite complex. We can say then I want to go to address family, no VRF for the VPN v4 unicast, because there could also be a multicast. As an example, I want to see the neighbors if I do a get who are configured, not the operational state. Now here I would access the configuration in this case. But I could also make a replace, so I could replace all the BGP neighbors just for this configuration. That's kind of handy, powerful if I want to automate the BGP neighbors. Of course, you have to be aware, if you automate BGP and you bring down your inbound management network, you probably have an issue that you cannot connect back to the device. So yeah, but that's business logic. We have to be aware that we should not shoot in our foot by ourselves. Otherwise you have to go to the car and drive to the location. Maybe you have out of band management, makes a lot of stuff easier. Yeah. Another thing is of course interfaces. An interface loopback is a list, so we have to decide which key. So loopback 1 we want to edit, we want to get, we want to use, or physical interfaces. Now on Cisco many times, or many vendors interfaces, in the name they have the slash, right? If we would have an interface 10 gig 0001 always divided with a slash, and we would enter this here in the URL, this would not be the best idea, because it would say that must be a path. So we have to URL encode this slash if we want to use it as a key, right? So this is something you also, if you testing with virtual devices, you probably don't have a slash in the interface name. For example, if you use the CSR1KV, you only have gigabit Ethernet 1, 2, 3, 4, 5. You develop a really nice script, reads like a poem, you're really happy with it. Then the interface name on the product production network has slash in the name, everything breaks. Well, it only happens once, you will learn after that. Yeah, so in RESTconf we can use the REST concept to talk to our devices. There's also the way to have RPC calls, not completely REST, but we can execute RPC calls. There is even a way to apply Yang patches. There is a specific RFC for Yang patch, where we can have multiple patch sent. So we have some possibilities here. We have to see which one we use. But also here we have to be aware that an API call could time out, that the API call could not work, a device could be busy, so we have to also add some information. There was my biggest issue with RESTconf in one setup was that we had kind of a huge configuration. how the device architecture was. If we make Yang changes, it has to synchronize with their local database for the configuration, and if we make changes, the database or the device is locked, so we have to wait a couple of seconds and then retry. That's all the stuff you have to think about. Also, if a device gets bigger in production, you have much more configuration, it needs more time to synchronize. So maybe you do tests in your lab, everything works smoothly, but then you realize in production where you have, let's say, BGP full table, to make a change with some stuff there, it can just be much slower because the device is busy. Right? So that's also something you have to be aware, that if you build something in the lab, only because it works in the lab, it does not mean it will automatically work in production. But if you bring down a complete network, you will learn your lesson. Don't worry. That's part of the journey. I still did not make it to the first page newsletter, but I'm working on it. So, how would we, for example, use this in Python? A simple example, we would have a payload to change, to change the host name. We want to change it to RT01. So we sent the right format, the JSON payload. We need to specify the headers, so we have the accept header with the Yang data JSON, but also the reply, the error message, for example, we want to have in JSON. And RESTconf on Cisco devices use basic authentication, so we have here this top secret password here, where we send it also with the authorization header. Right. So this is top secret. I think it's ENS at lab. Yeah. And then of course we make our put, in this case, send the URL, the header, and this request library allows us to, if we have this Python dictionary, to automatically send JSON. So we don't have to make the import JSON and generate the JSON by ourselves. The library request will do this if we do it like this with JSON. If you do data equal payload, you first have to create the JSON. There are some small details of the libraries. If you work with them a lot, you will know. Yeah, it's also always good to see other code and ask why was it implemented in this way? Can I learn something from there? But it's in the end pretty simple. Questions? Who thinks RESTconf is better than NetConf? What are the main differences? Or why do you think NetConf is better? Fewer requests, bigger messages, we can make a lot of stuff at the same time. With Yang patch, you could also do some stuff. There is one major difference in my opinion that I not sure if what could be different, or what, when we do these API calls, which data do we edit? These API calls here, if we do one API call, it is on the running configuration. This is immediately. In Netconf, we have the candidate store. We can talk to the candidate store. We can validate. We can use the lock. We have one session and the session is open. This gives us much more possibilities to interact with the device. We can block the device. We can send stuff to the candidate store. Oh, it's getting late again. Candidate store. We can validate and then we can apply, we can discard the change, because we have one session, right? We have more capabilities there. We can also have streaming over this SSH session to get always a stream of data if we want to make streaming telemetry. This is not designed in RESTconf stuff. So this, for me, one of the major differences, that we can use the candidate store, that we can have a lock mechanism, so we can ensure that the next changes we are doing it and in a controlled way. Of course, with the patch, I have to confess I did not do anything in production with RESTconf and patch, because I have RESTconf, I have NetConf, so I can have all the stuff there. But it should be possible to also do a transaction, and if one fails, everything gets redone again. But if we implement it by ourselves, and each API call, because of REST, needs to be independent and stateless, it will immediately apply this configuration. And if we make, let's say, we create with one API call a new interface, with the next API call I'll create a BGP name, address family, and anything. If something fails, I have to do the undone by myself, because there is no state. There is no connection between the multiple API calls. The device that cannot know if we wanted to do this anyway or not. If we make one big Yang patch or Netconf transaction change, it's clear we want to do all this stuff at the same time. But the big plus for me is the possibility to have JSON. So that's also something that's probably GNMI is interesting to go, because it has some features from Netconf as well, a little more capabilities than classical REST. The last beer is a long time ago. More capability than RESTconf. It's extended lately. So yeah, RESTconf for getting information, it's in my opinion really nice, really fast. So if we want to get from multiple devices some information, we don't have to open a SSH connection. We can just make one API call, we have a JSON, we can work with it. That's nice. On the other side, there was lately also some issues with the web server implementation on Cisco devices with bugs. So if you have multiple protocols enabled, you can also hit multiple bugs or security issues. Of course, if we activate NetConf, RESTconf, it will restrict it that only the management IP addresses can access it and not the whole world, hopefully. But yeah, it's still more protocols running, more possibility to hit a bug. So we have to make some trade-offs and find the right tool set, protocol set for our solution we are building. One thing I can show you. Oh, my browser's restarted. Is the tool NetAut, where you can also make some REST calls to devices quite easy. I have to reopen it, sorry. So this tool here would allow us for, where is it, RESTconf, to send directly RESTconf and see what information we are getting back. For example, if we want to use the IETF interface gigabit 1 information, we will see that we get this kind of information. But we also can get it as a XML, then just the header is sent different. This tool is mainly tested on Cisco sandboxes, so should also work for other vendors, but you never know. So if you want to make push patch, you can also do it here. For example, you can also pipe, do different stuff. Yeah, just if you want to play around with the API to get a feeling. Any questions? Then I wish you luck with the CI/CD labs, and if you have any questions, let me know. Thank you.